Okay, I'm looking at question 2 in our Unit 4 revision quiz for maths methods. So we've got a question here where we have from a cliff top 11 metres above sea level, 2 boats are observed. One has an angle of depression of 45 degrees, 45 degrees, and is due east. The other an angle of depression of 30 degrees, and it's on a bearing of 120 degrees. Calculate the distance between the boats. Now, what I'm going to do to start with is find the distance of the boats from the cliff, and then look at the distance between the boats on the ground, so rather than trying to do the two together. So looking at those boats, we've got one that is at an angle of 45 degrees there, and we know that our cliff top is 11 metres above sea level. So we can find this value down here on the ground, on the sea level of that distance of the boat from the cliff base. And then we can do that for the other boat, and it is its angle of depression is 30, and we've got that height of the cliff there, and find its distance there. So using our right angle triangles first, so we have our 45 degrees, we can bring that 45 there as well because they'll have to add to 90. So then we are going to do, because we have our 45 degrees there, we've got our adjacent and our opposite. So we will go tan theta equals opposite over adjacent. Tan of 45 is going to equal our x over 11. So then our x will be 11 tan 45. Now this question, just checking if we, it's a tech active question, so that's fine. I was just double checking if we needed to use our trig ratios if it was a tech free question. So when we do tan 45, we know that that's equal to 1, so then we will get our x is equal to 11 there for our first distance that we were working out. And then doing our second one, we've got tan of, and in this case we're bringing our 60 degrees there. Some people will like to use the Z rule and bring the degrees down there. That's also fine as well. It'll just change the order that you put the values into your tan ratio for. So we've got tan of 60 is going to equal, and the opposite is y over 11. So then we will bring that 11 tan 60 over equals y, and we will work that out on our calculator, or if it was tech free we could have used our exact triangles. So if we were doing the triangles, we would have our 1, root 3 and 2, and if we have our 60 30, then we have our so for 10 60 would then be root 3 over 1, so we could use that root 3 on 1, and then that would just give us 11 root 3, or we could do that on our calculator, being a tech active question, and just do tan 60 times 11 and get the 3.52. If you're doing it on your calculator, and because we're going to be using those values in the next part of the question, keep all the decimals on there to keep your answer as accurate as possible. So now we turn to, we've got those distances on the ground, we're going to try and work out the distance between the two boats. So we're told that one is due east, and the other is at an angle of depression of 30 degrees. So, at a bearing of 120 degrees. So when we draw that, we've got one over here east, and the other has the 120. So if we've got a 90 there, it'll be a 30 degrees from that horizontal part, and we know that that distance, we're trying to find the distance between the two boats. Now we know that first distance there we worked out as 11, and the other distance here we worked out as and sorry, I should have got that, I just realized my calculator's in radians, so I'll just go back to that value up here. I just realized my value is definitely not right, that's 3.52, so I'm just going to go back and put my calculator in degrees. So always be careful of that when you're doing that. So mode, I'm going to bring that down, put that in degrees, and then when I do my tan of 60, I get 1.732. When I times by 11, whoops, I get 19.05, much more Makes a lot more sense there. But keep those decimals in your calculator, just like I said before. So I'm bringing that down here. Okay, so now we can do the non-right angled triangle part. So we've got, if we labeled it with our ABC, we've got our C there, and that's our little C here that we're working out. And then we can call these A and B, it doesn't matter which one. So we've got our C squared, or in this case we're using D, is equal to our A squared plus B squared minus 2AB cos C, and you will be given that formula on the formula sheet, obviously. So we've got our D squared that we're calculating is going to be 11 squared plus, and remembering to keep all those decimals in the calculator, squared minus 2 times 11 times 19.052 cos of 30. So then we can grab our calculator. The 11 squared is going to be 121. And then we've got that 19.05, so I'm going to bring that down, square it. That gives me 362.99. And then I've got 2 times 11 times that 19.052, so I'll scroll back and bring that down again. And that's going to be multiplied by cos of 30, which gives me 362.99. And so I've got a 362.99, and I'm taking away 362.9, so they'll cancel out. I'll be left with the 121 there, and so I get my D will be 11 meters between.